we move on to our next speaker, who is Alberto Diaspro. I cannot do him and his career justice by the short introduction that I have to give, because we're limited in time. But he's the director of the Department of Nanophysics at the IIT, the Istituto Italiano di Tecnologica. And he's the deputy director and chair of the Nikon Imaging Centre at IIT. And besides his very prolific academic career, he also co-founded a spin-off, Genoa Instruments, to develop a next generation super resolution confocal microscope. And he is going to tell us today about the Nikon Imaging Centre and how this advanced research environment shapes technology development and generates an attractive environment for collaboration. So over to you, Alberto.
Thank you, Claudia, for your kind introduction and for this invitation. Yes, so today I'm trying to give you an overview of the growth and development at the Nikon Imaging Centre at the Italian Institute of Technology. So this really was a growth starting from 2014, when Nikon established the Nikon Imaging Centre in Genoa. I have to say that this growth is parallel with the growth of the Institute that was growing from 200 people up to 2,000 people in a very short time, having a number of scientific activities that are in some way functional to the development of new tools and applications in microscopy. So the very first strong group we have are all the companies around all the groups in the Italian Institute of Technology. And these are our research lines: robotics, nanomaterials, life tech, computational sciences. All of them are using, in some way, the Nikon Imaging Centre. And on the right side, you see the joint labs with other companies in other fields. So it's really a nice environment to develop academic and industrial collaborations. About our group, we are in the advanced light microscopy node of Euro-BioImaging, and we have some other partners in terms of European contracts and in terms of connections, including a startup that we recently developed in Genoa, Genoa Instruments, and a project that is running, taking advantage of the fact that we have in the beta version or in the final version, the best Nikon instruments in our lab. So the main idea is to use what we have, all the methods we have, to merge them in a unique architecture. This is our growth. And so try to take advantage of all signals that you can collect using light. We have robots, we have electron microscopes, and we have development of laser sources close to our lab. But I would like to start with you just a few minutes to tell you that we are bringing into the Nikon Imaging Centre, in collaboration with the Nikon and with other companies developing illumination sources and detection sources, a label-free approach that is in some way integral to the development in fluorescence, super-resolved fluorescence microscopy, that is scattering methods. We are developing these methods because, and recently, we, using a computational approach, we found that this method can also be used in terms of application to characterize what we are suffering today, that is the coronavirus invasion. For this reason, I'm bringing to your attention, with this integration in the Nikon instruments, what we're able to do is to have a fingerprint of some infections, have the prediction of what we can expect when we have specific infections like the coronavirus, and also monitoring something in a very crowded environment like chromatin DNA condensation and decondensation. And we take advantage of the fact that we can compare our label-free results with fluorescence well-known results. In this environment, is really relevant developing also in collaboration with companies, laser companies and detection companies, we will see immediately, the approaches. So in this case, you see discover about the Muller matrix microscope that is able to produce 60 different label-free images integral to the fluorescence images. To shape the laser beam according to our need and working with other companies developing liquid lenses or tunable laser sources in collaboration with Martín Bocastelli in Barcelona and Peter Sagau, Baylor College. And we are also developing our own Zeeman effect laser that we are checking on the Nikon architectures. The Zeeman effect laser is a very interesting laser because the output is circularly right and left polarized light. So its interaction with superhelical structures like in the virus or like in the nucleus for chromatin can be relevant for multimodal imaging. Recently, in terms of nonlinear imaging and multiphoton microscopy, we are developing collaboration with Nikon and Fila, an architecture using this new Fila laser in order to be able to take advantage of this very compact laser for our new developments. But what I like, of course, are the developments with Genoa Instrument. That is a startup of the IIT, as many other startups that we have in IIT. Today, at the Italian Institute of Technology, we have 28 startups, companies. And with Genoa Instruments, we take advantage of the collaboration with scientists like Colin Shepard, collaboration with groups with Paolo Bianchini, that is also the one that allows the center to be always a functioning center and developing instruments in the center and having all the contacts with the Nikon company, not only in Europe, but also in Japan, and some other researchers. Here we developed, and Giuseppe Vici-Domini that was starting a new group, is starting a new group in the IIT. The main object of this new microscope is a detector that is that comes from the collaboration with Polytechnic of Milan and with a company. And this detector is a detector based on the idea of Colin Shepard and Jörg Enderlein of image scanning microscopy. So using 25, now 49 eyes to collect photons, but with the ability of collecting time of arrival of photons. So you can immediately understand that this kind of development are really interesting for optical microscopy, because in this way, we have the chance to perform super resolution, not only in space, but also in time, for lifetime, for example, maps. There are many other research lines around, including preparation of the sample. And in this sense, it's Paolo Bianchini driving this new activity related to expansion microscopy. Here we demonstrated that this can work also at the nanoscale. That is what we do with the super resolved fluorescence microscope that we have from Nikon. And also there is another aspect that we consider in collaboration with companies developing atomic force microscopes, that is the coupling of atomic force microscopy with super resolved methods. JPK was the very first one we coupled many years ago in 2012, in order to better understand what we are doing when we prepare the sample. In the past, we could see images with a resolution of 200 nanometer, but now we have the single molecule. And when we don't see a single molecule, we can have some assumptions, but it's also possible that we don't see that single molecule simply because the single molecule was not able to be in the place where we expect. And so atomic force microscopy allows to have a further check and a better understanding. Now, the lens, the detection side, the illumination side are all under control. But what we need now and we are developing today are artificial intelligence algorithms in order to take advantage of all the data we are able to collect. For this reason, our MOMICS, that is a multimodal optical microscope image correlation sensing architecture, is endowed of developments using a supervised training in the machine learning. So MOMICS is you watching your sample, and in the mid, artificial intelligence. At the Nikon Imaging Centre, when we started in 2014, we started, and I like to dedicate this slide to Jim Pawley, that was at our opening with Masai-san, that was that time the president of Nikon Japan. And we have core instruments. We develop our instruments, and we also have something that we are before that is not only developing or opening instruments to develop new architectural solutions, but it's something that is related to training of humans. So this is very important, is a very important chance that we have in collaboration with Nikon and with all the other companies. This is the reason why in all these years, we always had Nikon courses, schools, practical and theoretical schools in the Nikon Imaging Centre. And these are some of the past schools in Genoa. And we also had theoretical schools in Venice, always supported by Nikon and by this collaboration. The next will be very soon, so will be the end of November, very first week of December, and is the 6th nanoscopy school, as we call them. And among the speakers, we will have Giancarlo Ruocco from IIT for label-free approaches, as we do, Loredana Casales from the Electra Synchrotron facility in Trieste, offering synchrotron light for multimodal imaging. Cryo-electron microscopy will be part of the school, plus Laura Finzi from Emory, Atlanta, and Jörg Enderlein from University of Göttingen for single molecule spectroscopy and imaging. I hope to see some of you for this school in Genoa. We have a limited number of seats, that is 50, in order to have no more than 3 people for workstation. And on the very first day, we have 200 seats available in the city center of Genoa. And in case you want to come back to another activity supported by the Nikon Imaging Centre, we are waiting for you in this summer in July in Varenna for a multimodal and nanoscale optical microscopy. This is to say, and this is the end of my very short presentation, this is to give you the feeling, the flavor of the fact that thanks to the development we had and the growth we had in the Nikon Imaging Centre, we were able with Nikon, but not only for Nikon, we have also interactions with many other companies in the field, including Zeiss, Olympus, and Leica Microsystem, or Aberior. Our collaborations are not restricted to one company, but the existence of Nikon Imaging Centers is really supporting other contacts with companies in the illumination side. So Coherent, Spectraphysics, Fila, and other companies, or companies in the detection side from Amamatsu to other Italian companies. And this is source of growth, continuous growth in our center. At the very same time, in parallel, we strongly think that training people is one of the duties we have. And I think that all of you also know that it's very difficult for companies and for academic research laboratories to find people for working in the optical microscopy field at a very high level, the high level requested by the times we are living now with super resolved methods or label-free approaches. So this is the end of my presentation, and thank you for your kind attention.
Thank you very much, Alberto, for this interesting overview over all the different activities going on at the Nikon Center. And the very last comment that you made actually brings me directly to a question that came in the chat, because you mentioned the high level of expertise required for people working with these technologies. And we had a question here on how accessible some of these new technologies you're developing are for researchers from different research areas, and how much of training is needed, and if not, do they get the support at your site? And yes, then I think in the next step, how easy is it to transfer this knowledge then to a wider community, and maybe the setup that comes with it?
Well, thank you very much for this interesting question. I have to say that I share this, let me say, job with Paolo Bianchini that is very strong in this, as all the others in the group. It's comparatively easy to come to the center, apart from this specific time at coronavirus, where we have more limitation in terms of person in the labs. So simply you can write to the Nikon Imaging Centre asking for a period to stay. And I think that in 1 week or less, 5 days, we can give you not only a flavor of what we do, but the idea of which kind of expertise we need and which kind of background knowledge we expect people have in order to start working with us or with companies interested in this kind of developments. We don't mind, or I think that also companies, sometimes they don't mind that you are skilled in a precise area. But what we need is that you have a really background knowledge, and that you started working with an optical microscope, understanding what it's doing, and with an optical table. If you come to the Nikon Imaging Centre, you can take advantage of this chance, and we can offer some logistic support. For the economic support, we can offer some, let's say, low price accommodation or some other help in terms of instruments, computer, and tools when you stay with us, and in collaboration with companies. So I think that this is useful both for academic and industrial research, as you are, showing here in this very important series of seminars.
Thank you very much, Alberto. That looks like it is. So we already had the comment in the chat as well that the summer schools in Varena are really worth attending. So I can see that your training is highly appreciated. We have some questions in the Q&A where we probably don't have time to answer them now. But just for the audience, we will take a look at all of the questions and try to answer them either during the meeting, or if we don't find the time, we will follow up afterwards. So your question is not lost. Please type it in and we will take care of it. I have one very short question also coming in, that is, because you mentioned the different collaborations with different companies as well. Do you ever find that there's competition or competing interests that restrict your activities in terms of, since you're working closely with Nikon, was it easy to set up a startup in parallel, or is it?
Yeah, in this collaboration, very shortly, we never had a specific request. We simply continued our research, offering our results. And in the Nikon lab, we took advantage of the Nikon instruments. So they fit very well in practical terms with some of the Nikon microscopes. But this does not mean that we don't have collaborations with all the other companies when they are interested and they come to the lab. I think the lab is the place where, at the end, what is relevant is to have discussion and to understand if what we do can be applied in the best instrument or in the best development you have on the market or in a beta stage. So we never had problems in this, and we also kept the knowledge separated company by company, so never merging them if they don't want, when they don't want.
Yeah, this is a very important point, Alberto. I think we should all remember that both companies and academia are, of course, very much driven by this passion for research questions and technological challenges, and that's really a common denominator among both sides here. Thank you very much for your presentation.